Alright guys, so notation for powers of cosine, sine and tangent. So if n is a positive integer, then cos n means cos theta raised to power n, and sine n theta means sine theta raised to power n, tan n theta means tan theta raised to power n. Remember, this n in the middle of sine, cosine, tan and theta is power. So we can see in the previous example where I did apply the following identity: tan square theta equals to tan theta all squared. Okay, so they are the same thing. Sine square theta equals to sine theta all squared, and tan square theta equals to tan theta all squared. Okay, so those identity holds and they are equal. So let's look at example. So we can simplify values with respect to the following parameters. Although they don't apply much like that, but we can always apply them. So we can simplify this. So look at this: sine square x all over cos square x is the same thing as sine x all over cos x, okay, which is the same thing as tan x all squared, which is the same thing as tan square x. Can you see how the identity applies? So this is how you can use it to work. Okay, so another one is sec square x minus 1. Okay, so let's try to prove this. So this is a, this is b, just deriving these identities. So we have sec square x minus 1 equals to apply the identity that we just discussed. That would be sec x all square minus 1, okay, which is, so that would be equals to, sorry about that, this marker is just misbehaving for now, so let me clean up these jargons. So this is square minus 1, and this is the same thing as what? So if we could write it in terms of cosine, right? So this is 1 over cos x squared minus 1, okay, which if we open we have 1 over cos square x minus 1. If we add it together we have 1, change to single fraction, we have 1 over cos square x all over what? Yep, all over cos square x. Okay, you know that from the Pythagoras identity, 1 over 1 minus cos square x equals to sine square x all over cos square x. If we apply the power identity again, we have sine x all over cos x all squared, which is tan x all squared, which is tan square x. So the power is always the same thing, and then you can use it to manipulate expressions as well. So this is how that work, and very simple. So you are going to try this out. Okay, try this out. So for the expression, you can prove the identity using the simplify the identity using the power. So let me say simplify this identity. We have cosec square x minus cos square x plus sine square x. Okay, so try it out and let's see what you get. B cos square x, okay, oh sorry, cos square x cos square x. Let's leave it at that. So try it out and let's see what you get. Example 6. So for example 6, let's check if 1 plus cot square x equal to cosec square x. So let's check. So from the left hand side, we have 1 plus cos square x equal to, so let me just write it here. So this is equals to 1 plus, apply the power identity, 1 plus cot x all squared, which is equal to 1 plus, we can change it to, okay, so let's change it to that. So 1 plus cos x all over sine x, okay, squared. Yep. So taking it further, we have, if we open that bracket, because if we don't open we cannot simplify, that will be cos square x all over sine square x. If we change to single fraction, we have sine square x plus cos square x all over sine square x, okay. And then you know that sine square x plus cos square x equals to 1, so this will be 1 over sine square x, which is cosec square x. So you can see it is true, so it is right answer. So that is also true. Alright, trigonometric identities involving negatives. So this is what we have now. So when you have this negative sign, they make meaning. So cos minus theta is always equals to cos theta. We saw the proof under negative angle that it is always equal. So cos is an even function. Okay, cos is an even function. We are going to understand more on this when we get to trigonometric graph. Sine is an odd function. Okay, because sine minus theta is always equals to minus sine theta, and tan minus theta is always equals to minus tan theta. So tan is also an odd function. So these are called the odd and even function identity. Okay, so how do they work? We've seen earlier that if we have tan minus 50 and we apply our negative angle, we have tan 360 minus 50, okay, which is equals to tan 310. 310 is in the fourth quadrant and tan is negative in the fourth quadrant, so that will be minus tan of formula for acute angle in the fourth quadrant, that's 360 minus theta. Okay, 360 minus 310, that will be minus tan 50. Can you see that tan minus 50 degree equals to minus tan 50 degrees? So instead of applying the long formula, we can simply just simplify and take the values. Okay, so that is what it means. So identity help you to apply shortcuts to simplify things. Okay, so and also we can have that cos minus 20 equals to what? Cos 20. Okay, we don't need to prove it, just apply it and see. Sine minus 120 equals to minus sine 120, okay, which will be equals to minus sine 60. So this is how you can apply those identities to simplify problems. So trigonometric identities with pi over 2 minus theta. Now remember that pi over 2 is in radian. If we change it to degree, that will be 90 degree. Okay, pi over 2 radian equals to 90 degree. So this expression can also be rewritten as in terms of 90 degree. So therefore cos 90 minus theta equals to sine theta. Okay, complementary angle, they use the principle of complementary angles. Okay, so and they are also called co-function identities. Co-function identity. Okay, we've used one of them and we saw how it works. So sine 90 minus theta is also equals to cos theta, and tan 90 minus theta is equals to 1 over tan theta, and then you know that 1 over tan theta is cot theta, right? So they are called the co-function identity. Okay,